evaluation of double integrals. Okay, so to evaluate double integrals, we have some conditions. So there are different types of conditions to evaluate double integration. When compared to simple integration, so in simple integration, we can done directly. The integration can be done directly. But in evaluating double integral, there are some rules, right? So here, suppose when choosing definite integration, the definite integration means within the range will be given to you, right? Suppose when all the limits are constant limits, then in that case we must choose. The integration can be done any time. Suppose when taking with respect to x, then with respect to y. After completion of with respect to x, then the integration can be done with respect to y. Or suppose if we choose with respect to y first, then the integration can be done with respect to x sub x. Okay, so that is the first condition. Suppose when taking second condition, when the x range is constant range, then the y range in terms of variable. Suppose y must be in terms of x. So in this case, the integration can be done first with respect to variables. So here we have taken y range is a constant. Y range is defined in terms of x. So means the integration first can be done with respect to y. Then we will get the total integration into x. Total integration will be converted into x. After that, integration can be done with respect to x in the limits, right? That is the one procedure. Okay. So these are the two conditions. And when solving double integration, here suppose when taking with respect to x, then y must be considered as variable. Y must be considered as constant. Or suppose with respect to y, if we take first, then we have to consider x is a constant. So these are the three conditions we have to follow. Okay. Now, evaluation of double integrals when the region is defined in some range. Suppose when the range is not given. So in this case, how to get integration? So that we see. Okay, I am taking one problem. Suppose here evaluate double integration x into y x plus y dx dy. Here the region is not given. So here it is given as over the region or bounded by y is equal to x square and y is equal to x. See here the limits are not given, but we have to choose limits from the given curve. So here one curve is given and one line is given. See it. Y is equal to x square, which means we can compare with parabola. We can compare with x square equals to 4ay, right? And y is equal to x, which means what? Which is a straight line. We can compare with ax plus by plus equals to 0. So this is the straight line that we consider. Now, first we have to find limits. For that, by taking intersection of both curves, curve and line. See here, y is equal to x square and y is equal to x. Now, by substituting y is equal to x here, then what happens? X is equal to x square. Then x minus x square equals to 0. Then x into 1 minus x is equal to 0. Then what are the interval is? For x is equal to 0 and x is equal to 1. Now, when x y is equals to x. Here y is equals to x, y is also y becomes 0 and the rate is equals to 0. Then what is the point? In this case 0 comma 0 with the 1 point. And similarly when x is equals to 1, when x is equals to 1, so y is equals to x means y is also 1. Then in this case the point becomes 1 comma 1. Now using these points, okay, we're taking here x square equals to y cube means it is like that y axis, right? So we can choose like this. So y is equals to x square or x square equals to y. And next one, here 1 point next here 0 comma 0 is a 1 point. And another point 1 comma 1 means suppose take like this 1 comma 1. Then we need intersection point that will give the area, right? So for that by joining from origin. So which is the defined form? So which is the defined form? Which is the defined form? Okay. Now you have to choose limits. Okay. So what are the conditions to limit? First you have to fix its value. Then we need y in terms of x. See the procedure. Here choosing limits mode. Here we can choose x is from 0 to 1. 0 to 1 from x-ray along the line. Then you have to choose y then along the curve. Right? Y from along the curve. So here y can be taken like this. So along the curve means y in terms of x. So here x is like to what is the line? What is the line? Line equals to x, right? So y is from x is like to x. X is like to x. This is the choosing of y. Now the integration, the area becomes the integration of x plus y dx dy becomes. So here x is from 0 to 1 and y is from x square to x, xy into x plus y dx. Now after taking integration we get the integration, right? Now x is from 0 to 1 here by multiplying it first y is equal to x square to x, x square y plus x y square dx dy. First we have to take the respective y means the representation, right? After divide x is from 0 to 1, x is from 0 to 1. Then by taking with respect to y here, by taking with respect to y, then x square into with respect to y integration y square by 2 plus x into y square integration by 2 by 3. What the value is x square into x dx. X is from 0 to 1. Now instead of y, operand later. Then x square by 2 to y square, x square plus x by 3 into x cube. Instead of y, substitute the upper volume and lower volume instead of y. Here x square into x square whole square, x power 4 into x square, x power 6 by 2 plus x into x square whole cube, x power 6 into x power 7 by 3. Total with respect to x. Now taking different integration, then we will get the different, right? Plus x is from 0 to 1 x square x power 4 by 2 plus x power 4 by 3 minus x power 6 by 2 minus x power 7 by 3 whole dx. 98 with respect to x here. Here integration x power 4 power 5 by 5 into 2, x power 5 by 10 plus again x power 5 by 15 minus x power 7 by 7 into 2 14 minus x power 8 by 8 into 3 24. The value is 1 by 10 plus taking upper and